Hi, this is Venkatesh Prabhu. I'll be discussing about the performance equation in a batch reactor, how we need to derive the model for a batch reactor. So first let us take the model. So performance equation for a batch reactor based on the growth model dx by dt is equal to mu x. Actually, this is a first order kinetics. The rate of change of biomass is directly proportional to the initial concentration of the biomass which is added as inoculum. The proportionality factor is going to be the specific growth rate. We need to convert this biomass model in terms of a substrate model, that is differential equation in terms of ds by dt, and substituting the model for the specific growth rate and model for the biomass. Then when we are applying the boundary conditions for this, then we getting a model for a batch reactor. Let us do one by one. So see, dx by dt is equal to mu x. You take this as equation 1, and your equation 2 is, there is a model, that is dx by dt. This is a relation. Dx by dt is equal to minus yx by s of ds by dt. So we could replace dx by dt in terms of ds by dt. Let us take this as equation number 2. Then mu is the specific growth rate. This can be written it as monad model mu max s whole divided by ks plus s. Then we need to substitute the model for the biomass. Model for the biomass is arrived from the yield coefficient yx by x is equal to delta x by delta s in terms of minus. That means this is going to be x minus x naught whole divided by s naught minus s into minus sign minus is equal to yx by x. That is x is equal to x naught plus yx by s of s naught minus s. So this is model for the biomass. Let us take this as equation 3. Then on substituting equation 2, 3 and 4 in equation 1, we will be getting minus yx by s of ds by dt is equal to mu max s whole divided by ks plus s into x naught plus yx by s of s naught minus s. Let us take this equation as 5. On rearranging this equation and applying the boundary condition from S0 to S under time 0 to t, then we will be getting the answer. Let us rearrange this. ds by dt is equal to 1 by yx by s minus mu max s whole divided by ks plus s into x naught plus yx by s of s naught minus s. This is equation 6. Let us take. Then using variable separable methods, we need to bring all the variables which is in terms of substrate in the left hand side and the time in the right hand side. Then this could be written it as ks plus s into ds whole divided by s into x naught plus yx by s of s naught minus s whole bracket is equal to minus 1 by yx by s of mu max into dt. Take this as equation number 7. Then this could not be integrated, this portion could not be integrated directly, so we need to partition it, that is integration by parts. Separate it, then we can go for integration. So this term could be written it as ks whole divided by s into x naught plus yx by s of s naught minus s into ds plus s into ds whole divided by s into x naught plus yx by s of s naught minus s is equal to minus 1 by yx by s mu max dt. Let us take this as equation 8. This portion we need to integrate separately, that is find out we should solve by integration by parts, separate methods. That means 1 by s into x naught plus yx by s of s naught minus s is equal to a by s plus b by, we are separating it, x naught plus yx by s of s naught minus s. Let us take this as 1. Then on simplifying this, how we can simplify that is 1 is equal to a into x naught plus y x by s of s naught minus s plus b into s. We'll take this as 1 itself. So we need to find out the value of a and b here. You could not find out a and b immediately, so first we need to substitute s tends to, when we need to cancel out this s, what we can take is s tends to 0 first. Then when you substitute s for 0, this equation is going to be 1 is equal to x naught plus yx by s of s naught alone. Then a is equal to 1 by x naught plus yx by s of s naught. So this is the expression for A. Then B how we need to substitute is, then we can substitute the expression for A here and we need to cancel out this. So S tends to S naught. Then 1 is equal to 1 by x naught plus yx by s of s naught into x naught plus yx by s of s naught minus s naught. So this whole term is going to be cancelled. Then we can simplify this model as, how we can simplify the model. 1 is equal to x naught whole divided by x naught plus yx by s of s naught. Let us check again. Yes, 1 is equal to x naught plus yx by s of s naught. So this is going to be, so we can rearrange this as x naught plus yx by s. I missed the another term. This is going to be plus bs naught. S of bs naught must be there. So plus bs naught. So first we can bring this to the minus sign. 1 minus x naught whole divided by x naught plus yx by s. S naught is equal to bs naught. That means x naught plus yx by s of s naught minus x naught whole divided by x naught plus yx by s of s naught is equal to bs naught. So x naught and x naught will get cancelled. Then s naught and s naught will also be cancelled. Then final equation is b is equal to yx by s of yx by s. Both s naught and s naught will get cancelled. X naught and x naught will also cancel. So b is equal to yx by s whole divided by x naught plus yx by s of s. Now what we can do is, we need to substitute in the original equation, and that is ks into a. A is going to be 1. So the value of a is, what we can write is, what is the value of a? X naught plus yx by s. So x naught plus yx by s of s naught into s plus, what is the value of b? Yx by s, x naught plus yx by s of s naught into x naught plus yx by s of s naught minus s ks ds plus 1 by x naught plus yx by s of s naught minus s into ds is equal to 1 by yx by s mu max dt. So this is the equation number what we can give. Already in the 8 as given. Let us give the equation number as 9. So the ninth part we need to derive. How we can derive this, integrate this equation 9 is, this is the ninth equation. So we need to take the common term here and the constant term is separate. So let us do again. So Ks 1 by s, this term, how we can write is 1 by x naught plus y x by s of s naught is going to be common. Then 1 by s ds. So this is constant, there is no variable here. Then the next part is, we could take the common term which is available here. So this part and this part is common here. So we will take a common term. How we can take the common is, we could take the common. First let me write that equation. So commonly when you are considering plus yx by s whole divided by x naught plus yx by s of s naught into ds whole divided by x naught plus yx by s s naught minus s plus ds whole divided by x naught plus yx by s s naught minus s is equal to minus 1 by yx by s mu max dt. So how we could take this is 1 by x naught plus yx by s s naught, let it be, into 1 by s into ds plus, we'll take the common term. Common is going to be, here one ks is missed, here is also ks is missed. So ks yx by s plus whole divided by x naught plus yx by s naught plus 1 into ts whole divided by x naught plus yx by s naught minus s is equal to minus 1 by y x by s mu max dt. So this is equation number 10. We will take this. So this part is going to be the easy part. The part which is this part is directly we can integrate. This is integration. After when we go for substitutions we need to do. I'll replace the ds. How we could replace the ds here is, yes, ds can be written it as minus 1 by y x by s dx. Because it is integration, ds term is replaced. So the next part is I should write the entire equation and substitute it after substitution. This is going to be ks ds whole divided by x naught plus yx by s of s naught into s minus 1 by yx by s of ks into, what is the term, ks into yx by s. So this is yx by s whole divided by x naught plus yx by s naught plus 1 into dx by that entire term, that is x naught plus yx by s of s naught minus s is equal to minus 1 by yx by s mu max dt. Now this part could be replaced it as x alone. Then this could be rearranged. Finally, we'll get the model as ks by x naught plus yx by s of s naught into 1 by s ds with the limit of 1 by s ds. I'll write the integration here. The limit of s naught to s, remove this, is minus 1 by yx by s of ks yx by s plus x naught plus yx by s of s naught divided by x naught plus yx by s naught into dx by x is equal to minus 1 by yx by s mu max dt. Here is also we could substitute the limit as x naught to x and substitute the limit as 0 to t. We will consider this as equation 11. The final equation we are arriving. So the last term is, so the last term how we need to write is Ks by x naught plus yx by s naught ln of s by s naught minus 1 by yx by s of that bracket term, the whole bracket term. What is the whole bracket term is is Ks yx by s plus x naught x naught plus plus yx by s naught whole divided by x naught plus yx by s of s naught ln x by x naught is equal to minus 1 by yx by s mu max t. This is the final equation. We could also, if you want, we will rearrange this further by rearranging it as ks x naught plus yx by s naught ln s by s naught minus 1 by yx by s bracket. The whole term is yx by s of ks plus s naught plus x naught divided by x naught plus yx by s of s naught ln x by x naught is equal to minus 1 by yx by s mu max into t. So this is the final equation for the performance equation for a batch reactor. Thank you.